Welcome, everybody. Tonight we're going to be working on Unit 10. You can see from the title here, the title is Data Fuel for AI. And I'm going to switch over to our slideshow here. And so last week we talked a lot about neural networks and deep learning, if you guys recall, pretty heavy topics. And once again, the true underpinning of all AI really does come down to the information that we feed into it and the quality of that information. These are the main topics we're looking at in this particular unit. So data literacy, the structured versus unstructured data thing again. We're also going to start looking at data mining as a concept, and also how data is stored. And this is a big issue in today's society because and we're seeing it happen, and I find this fascinating right here in our own district. Like, we've had these huge headlines now, how Microsoft Corporation is coming in, buying big tracts of land right along the interstate corridor, and is actively building data centers. Why? Because of the anticipated growth and need from artificial intelligence is the primary driving factor. But even without that, the need for data storage is growing at a huge rate anyhow. AI is accelerating it. So it's become a real, true issue. We'll start by talking about this topic of data literacy. And you'll notice that these are the topics within this topic that we're going to be talking about, why it's important, disadvantages, obstacles, the current conditions, and how you can improve your data literacy. But what you will definitely figure out is that not everybody is data literate. And even more fascinating, and this is kind of a little aside, frankly, is how you can have two people look at the same data and draw very different conclusions from it. And I think that's really fascinating. And sometimes it's all in the presentation, by the way. So there is a formal definition, and they're saying here that Gartner defines data literacy as the ability to read, write, and communicate data in context. And that part of it is really important, right? If I, throw a number at you, like if I throw the number 5 at you, okay, that's great. What's 5 all about? Well, I have 5 dogs. Well, that's in context. That means a whole lot more than if I just throw the number 5 out there. All right. The other thing that they're kind of pointing out here is stakeholders have to kind of know what the data is about. Where is it coming from? How is it put together? How was it gathered? Like, is there like a methodology behind how it was gathered compared to other approaches for gathering that data? And are we using it to solve some sort of a problem? And then if we are, what are the results of what we're trying to solve can do for the people that are interested in it? There's a lot to it. There's some problems with people not being data literate. And real frankly, folks, the more you learn about this stuff, what you are going to discover is how illiterate people are about data, even more so than language in many cases. So like, for example, if you're not literate about data, you can't take advantage of the information that you have, right? If you're in business, you might lose competitive advantage, basically. So it says they're losing out in competition where everyone else is leveraging data for decision making and your company is not. If you walk into a business and they change how they operate, do you think that they're changing how they operate just because? Well, let's try this. Let's see what happens. Sometimes it's like that, but more often than not, business decisions are driven by data that indicates, well, you know what? We stopped carrying that because nobody was buying it. How do you know that? Well, we looked at our data. Our data said nobody was buying it. Or how about this? Making the wrong assumptions, leading to wrong decisions. So you can look at the data, assume the wrong thing, and then you make the wrong decision, and oh my God, things are a train wreck, right? Because you're not really reading the numbers correctly. This little acronym, the GIGO, garbage in, garbage out. If you have good data feeding into your system that you're analyzing, you get good results. If you have garbage coming in, well, you get garbage results. So the quality of the data is pretty important. And I like this, right? Um, right? That's kind of funny, right? And I'm sorry that I scrolled way too far here. All right. There's a bunch of things that will roadblock you though in the process of doing this, and sometimes it is the way an organization operates. Like so they're pointing out company cultures. That is kind of an issue for some organizations. Maybe you work for one that has this kind of an issue. Um, but the people who run the place have to understand and basically look at their numbers. Like a good manager looks at like their receipts and their bills and their statistics and makes decision based upon that, right? Bad companies don't do that. They don't use the data to guide their operations. Not that that's always wrong, right? But data is the driving force behind business and organizations. In business, often the motive is profit. In other organizations, often the motive is efficiency, right? So both are important. Often organizations don't have the expertise within the organization to take advantage of working with data. So for example, just a few years ago here at Gateway, we did not have any people on our staff that were data analysts. Now Gateway has two of them, two full-time data analyst people right here within our institution that analyze our performance, like on the program level, a course level, our economics, our demographics, and we look at metrics like how many people are graduating, how long does it take them to graduate, how many men do we have, or women, or Hispanics, or whatever. They look at all of those different pieces. In some cases, data is available, people look at it, but you are not really authorized to say, hey, you know what, even though you're looking at that information, we're not using it, sorry. Right? And that's the empowerment piece. That's something that we kind of often felt frustrated with here at Gateway as faculty members, because we would see things like, hey, you know what, like nobody's signing up for this class, so we really need to have this class, that kind of thing. If looking at the last bullet here, it says if the data itself is incorrect, insufficient, irrelevant, making it unusable for data analytics, that's a really big problem. So sometimes the data that you have, if it's wrong, right, and you're using it to make decisions, and here's one of the things that will happen to you as a data person, because it's happened to me and it's happened here at Gateway. We were asked as a department to look at metrics generated through some state level data dashboard. And then we were supposed to go, okay, here's your numbers from the state. How do you respond to this? You guys are doing terrible. And then I looked at the numbers and I said, those numbers aren't correct. We don't have 345 students in our data program. I kid you not, right? At the time we had like 30. I'm like, so you're measuring us against data that's inaccurate, and you're telling us what are we going to do to fix things when the data you're looking at is wrong? This is really enlightening to me, because here we are, people in the institution thinking, okay, now we're data driven, and they're looking at the wrong data. And when I pointed it out at first, the reaction was a very negative one. Like, what are you talking about? Our data is not wrong. And then when I started showing them how it was wrong, they're like, oh, gee, thanks for pointing that out, right? So they don't want to admit that they're wrong, but this is a thing that happens a lot too, is sometimes people are using the wrong information or incorrectly framed information to make decisions. That's a pretty scary thing when you think about it. Right? The bigger an organization is, the scarier that can be. So these are things that you want to think about, like within your organization. Like maybe you're already working somewhere, and these are questions. These are all very valid questions. Is how many people in your company can interpret statistical operations such as correlations? You guys like take that stats class? Like if you're taking it right now, it's like, why do you take it? Because you need to understand even what the word correlation means. You have to correlate one piece of information to the other, right? Like, for example, if I signed up more students, well, then we have more uh, tuition dollars, right? So number of students correlates with the money, the revenue of tuition, whether it comes from financial aid or out of their pocket, right? Those are correlated information pieces. It says how many managers can create a business use case based on concrete numbers. So for example, if let's say every I don't know, I'm just gonna like, I don't know, every time St. Patrick's rolls around, you know, I ordered more cases of green beer, right? The other times of the year I don't order any because nobody drinks green beer on days other than St. Patrick's. And by the way, I would never drink green beer. That's just me. It's probably cancerous. But you would base like how many cases you would buy. What would you base that on? I would look at my numbers from last year. I'm like, we bought 5 cases of green beer. We only sold 4. So let's only order 4 cases this time. It's better to run out than to have too many, right? Because after St. Patty's, nobody wants to have it. How many managers can explain the output of their processes? You would be surprised. Some managers are really astute. They understand how their business operates. There's some that don't. And I've seen this more and more in my life, especially as I've gotten older. If you have an organization that has good management, that knows what's up and how the place is running, the place will run much better than if not. And then to correlate that to data science a little bit, and how many data scientists can explain the output of their machine learning algorithms? Well, you would hope they would be able to. But what if they really can't, right? And that's why there's data scientists and data analysts, and they're different people, right? The scientists are very high level people. All right. So they talk about data literacy here, and I'm not going to dig into this little thing, but I would encourage you, if you want to think about this and follow that link and read up on that link. There is this link here as well. And I would once again encourage you guys to try this. The last time I tried this, it was working. And I'm always a little pensive with these in PowerPoint links, and I'm trying to like open it up here. And I don't think this takes super long, but just to give you an example, if you were confronted by this scenario, right? Which one would you answer? And you should answer honestly. I'm tempted to click on this one, right? But I really don't do it daily. That's not my primary task, but I do it pretty often. So, I would probably click on that one because it's probably closest, right? So, and you just go through this process and it kind of tells you what your data literacy is. I guess this doesn't take too long. I would still recommend that you pop through this. You might be able to just do it right now while we're on the screen. What I think you will be shocked to find is, even though you're in the data program, and if you truly answer honestly, you probably still aren't ranking really high on the scale here. And that's kind of the point, right? The point is to not be afraid of things that look scary or look intimidating, and to explore them and to learn about them and open your mind to the possibility that you can wrap your head around it and get this knowledge, right? And that's why you guys are here, to do that. So what can we do to improve data literacy? All right, so they did a survey a while back. Almost 200 people responded, and so here's what they're recommending: the 3 most important steps to improve data literacy. And do you agree with these findings? So what they're putting in here is increasing training to improve data literacy. Sure, that makes sense. Support culture of data curiosity and critical thinking. Okay, I like that one a lot. And you can tell from the story that I just gave you guys about the data that was presented to us and the fact that I dare question it. Have you ever done that? Have you ever looked at like a newspaper article or any piece of information that somebody's throwing at you and go, Really? Does that really add up? Have you ever done that? I find my, and maybe it's like an old man thing or something, but I find myself get as I get older, I get a little more cynical about like, I don't know if I believe this. I want to look into it a little further. And the fact that a lot of data is publicly facing now, and if you can dig into the root data, you can make your own analysis of the data often. And I would encourage that. The other one was make it easier for users to access, explore, and interact with data. Sure. Now, some of the stuff that we did in the data analytics course where I had you guys explore data repositories just on a rudimentary level, like data.gov, right? The US government and federal level, the state level, and the municipality level all publish their data because it's kind of a thing that they do, right? They gather data and they publish it, and it's out there for the taking if you know where to look. Um, you know, but how many of us really? I mean, hey, I got some free time. I think I'll look at some data. That's not typically what most of us want to do. But if you're intrigued about something, I would encourage you to do that. And if you are naturally inclined that way, well, kudos to you, right? I always was kind of a little bit data driven, but I never really kind of latched onto it as being like a whole standalone thing. I just thought it was an aspect of something else. But what you guys are learning in this degree, not only is it important for AI, but hey, man, somebody's got to do this job. Somebody's got to look at the numbers and understand what they mean, right? You can go down this scale and read all of these different things, but the top four, right? Increase training, support a culture of it, right? Make it easier to access the data. And then the fourth one is improve the data quality to increase trust in the data. Now you can imagine the next time I'm going to be presented with this state level data that the school presents, I'm going to be all over that stuff because the last time it was all wrong. And they were guiding our programs and their existence, frankly, on bad data. Can you imagine that? So next time I'm looking, it's kind of like it's like, hey, I didn't spend that much money. Where did all the money go in my account? Right? That's kind of data that you maybe would be a lot more tangibly motivated to look at. So notice how they kind of break down data literacy into these areas for analysis, narration, and design, and these like overlaps and stuff that they have in here. But basically, it's a combination of all of these things built together. Notice the interpretation, the clarity, and the storytelling that kind of all get to data literacy. Because there's kind of a bunch of stuff that goes on here to get to that point. It's not just looking at numbers, right? It's kind of putting it all together, drawing a picture with it, really. All right, make your data clear, right? Um, so yeah, not all data is clear, right? And as you kind of deal with large data sets, sometimes you can look at them and go, I have no idea what this is. If somebody points out, oh, that's GPS coordinates. Oh, that makes sense now that I'm looking at it, right? But if you're not told, so data often needs to be framed so you understand it. Also, it says here, make it known. So in other words, there's an awareness piece. So it says communicate the change and case for change and begin to create ownership of the solution. Make it real, right? So if you're going to like use that data to turn it into something, and it has like visual or it has an impact, yeah, it's going to resonate a whole lot more. The organization itself also has to be, in the camp of like, all right, we're going to look at data, we're going to drive ourselves with data, but we also have to make sure that all these other things are aspects as well. So you can make it happen. Gateway is trying to do that, by the way. We're trying to be more data driven so we can be more efficient. It really makes sense. But man, that data better be good, for sure. And then if there is value in the data and it's good data and you're making decisions with it, that you can make those decisions stick, even though they might not seem like the right thing. Numbers don't lie, folks, right? That's one of the beauties of quantifying things, they don't lie, All right. We've looked at this concept before too, where we've talked about structured and unstructured data. So we kind of have a familiarity with what these means, right? So just kind of a quick recap here. Structured data has a format. So in other words, like for example, if you work with a database, you put things in rows and columns, and that what you put in each column is predefined as a data type and what that information is. Notice how it says usually presented in a table format like a spreadsheet or a database table. Right? And all the fields, all the data is precisely defined. It's not accidental. So that's structured data. So here's some examples. It says credit card numbers and addresses of customers in the bank, the records of purchases at a supermarket, traffic flow at a website. Yeah. And I think most of you are aware of this, right? But you go in, let's say to a store and you buy something, you use your credit, debit card, whatever. Your purchase is associated with that card number. So you might not have your receipt, but you can go back and say, hey, I bought it with this card. Oh yeah, there it is. We can give you a refund or exchange or whatever. Same thing happens at the supermarket. I always have kind of this issue at the supermarket where you go to some supermarkets and you can get the discount if you have your shopper card or your phone number typed in, right? But what's the trade-off? They're keeping track of everything you're buying. Right? You get the stuff cheaper, but they know that you like the peanut M&Ms, that type of thing. Every Friday he buys a 2-pound bag of peanut M&Ms. Or traffic flow at a website. Oh, this is one that a lot of people don't know. When you visit a website, folks, your IP address is captured, what operating system you're using on your computer, the type of web browser you're using, et cetera, et cetera. And if you're signed into your browser and you might be either on Facebook or Google or pick an online service that does data sharing, a lot of times that stuff's shared with the website too. So people, they know who you are as you're visiting a website. Weird, right? And it's all stored. All right. So here's kind of a little exercise. We're not going to obviously do this one, right, in the interest of time. But some stuff that you could do. And the reason they kind of point out these little things, you could literally do this one. So you're planning to create an AI model for a health wearable product, whatever that might be, like a smartwatch or something. Find a relevant data source from Kaggle, which has structured data. That's typically what you'd find there. And give an explanation on why it's structured. What's structured about it, right? Usually in tables, rows and columns. Columns or data fields have to be like numeric or text or calculated or whatever it is, but that's structured data. Right? Why is this good for AI? We've talked about this too, but to reinforce, it's really good for machine learning algorithms when the data is structured. It's in, as it says here, specific columns and rows, and very easy to query. So when your data is organized, it's easier to find stuff. That's really kind of the point here. Also, when businesses look at information, what they're saying here is that you can see a relationship. So for example, the more people I have walk into my business, the more stuff I sell. That makes sense, right? More people walk in through the door, we may have more sales. So what's the trick? We got to get more people through the door, that type of thing. They use a little bit different example here, but as you're gathering information, if you look at a column and it says customer name, well, I guess that's the customer's name. It makes sense. But we also have unstructured data. So you do have data either that's intentionally or unintentionally unorganized. This is really kind of a weird thought, right? So it says data that is stored in its native format and not processed until it's used. So this is really kind of a weird thought. So there's no fixed fields, there's no defined columns, there's no data types. And it's not necessarily something you can print out as a table, like a database table or an Excel spreadsheet. It's not structured like that. Here's some examples. Photos of employees in the company. So for example, I would think that most organizations would structure this data, but like when you're at your Gateway and you go get your student ID, they have you sit down in a chair or stand against the wall or something, they snap your picture, And that actually does go into a database, that gateway. And then if you ever lose your ID, you just go back to student service and say, hey, can I have a new ID? And they just print it out. Your picture's already in there. But can you imagine if that camera wasn't linked to a computer that stored it and the person didn't save it to your account, and somebody just had a camera? It's like, I took a picture of all the students. All right, great. Here's a JPEG number 43. Which student does that go with? Well, that's unstructured. You'd have to like go, whose picture is this? And you could get it wrong, right? So that's an example. Email messages sent between the vendor and a customer are kind of unstructured. Those aren't really in a database per se. Or maybe songs recorded in an MP3 format where the songs aren't necessarily titled in the song title. They just have some generic name. That happens too. Like if you rip music from a CD and turn it into an MP3, it doesn't necessarily grab the song title and put it on there. You might have to put it in there manually, right? So then you have to structure the data. So those are some primitive examples. All right, so they have you look for unstructured data on Kaggle. Also, here's the advantage. There are some advantages to data not being structured. I did some consulting work not that long ago, it was a couple of years ago, with a startup company out of California. This is on a contract. I knew the owner of the company, and he contacted me and says, hey, we're building this system for this chain of restaurants. And the way that the restaurant did its data is they used this, they called it a data river is what they called it. So anytime somebody would, for example, a customer would walk in and pay their bill, the data from that bill would go into the data river. And then somebody would come in, a vendor would come in and deliver a case of vegetables. Then the invoice from that transaction and the check that paid for it went into the data river. It wasn't like it didn't go into a database. All the data just got thrown into this pool, basically. And the reason they called it a river is the data just kept coming. Customers would buy stuff, vendors would deliver stuff, bills would be paid. It all just got thrown into this pool. And then in the aftermath, they'd be like, well, how many customers do we have today? Well, they could go into that data river and kind of pull that information out. So there was no structure to it until they tried to figure out what they needed from it, right? So the reason a lot of people are moving to this type of approach is you can just kind of like, well, I captured the data, doesn't matter that it's not organized, right? But it's there, right? It's kind of like, here's kind of a real world tangible example. Instead of like when your bills come in the mail, instead of like putting them in the file folder in your file cabinet, you just throw them in a pile, and then it's like, where's the electric bill? It's in the pile. You know, this is a good example, right? It's not that the data is not there; it's just not organized. And what's kind of cool about this too is you don't worry about like structuring the data and like making sure that it fits into this tiny little format in order to capture it. You have it, right? So some advantages to it. All right, there's advantages and disadvantages to both, but let's take a look at a couple of these charts here. We will find a logical breakpoint, by the way, here pretty soon. We're coming up on an hour already, believe it or not. But if you look at structured versus unstructured, and you look at how you analyze this information, look at that very first row. When your data is structured, it's really easy to quantify it. So what does that mean? That means I can add it, I can average it, I can see how many records I have, right? Where with unstructured data, sometimes we're looking more at the quality of the data than necessarily crunching numbers on it. So qualitative versus quantitative. The structured data always has a predefined format. So if you have like a database for invoices, all of that stuff is going to be put in there in the same way. It's really easy to get to specific stuff. Where in unstructured data, like that data river I was talking about, it's like, well, it's in that pile over there, you know. And It could be a big piece of paper or a small piece of paper. We don't. Searching structured data, much easier. Unstructured, much more difficult, obviously, right? Rows and columns for structured, no rows and columns for unstructured data. Storage requirement for structured data and why we have it to begin with, because in the old days, storage was very, very expensive on computers. You need a lot less storage space if your stuff is organized, right? Unstructured data, well, that's a whole different thing. Could you think of other differences? I'm sure you could if you really sat and thought about it. All right, so let's start talking about like actual tangible items that fall into these categories now. And this is, I think, where it gets kind of interesting. Where we here at Gateway, when you guys you're learning how to code, right? So you learn Python, and then you learn, hey, there's these like things called data structures, right? Like a list or a dictionary or a set or a tuple or something like that, and how those are organized pieces of information. And then you start to learn that, well, information doesn't really have to be that organized. So you can just be in there. And we actually have very specific tools. So you can see the column on the left are what we call traditional database tools. The data is structured into formats. Now, here at Gateway, when we're teaching you traditional database technology, we focus on MySQL because it's an easy one to learn and it's open source, and it's very much like other full-blown server systems for databases. So these are basically database technologies here. Some of them lightweight, some of them not quite so lightweight. And no, these are not the only ones, right? MySQL is basically the open source version of the Oracle database. Postgres is another one that a lot of people use in coding. SQLite is a super lightweight, low footprint one that people also use for coding. And OLAP is a mechanism for interfacing with databases. But there's many, many other database systems. This is just a smattering. But these are traditional database structures: rows, columns, tables, relationships, inner joins, outer joins, queries, SQL code, all that stuff that fits with these. Then we have what this more modern approach that's been happening recently and has been actually kind of exploding in the data science area in particular, because we do have these organizations that gather so much data and gather it so quickly, there's almost like no time to structure it. A lot of web developers, so when we teach our web students here at Gateway how to, build backends for websites to store data, where often it's like, some users are going to put in a lot of info and some people aren't going to put in any info, but we still want to capture it. So we use tools like MongoDB. It doesn't use regular database tables with rows, columns, and data types, but it sort of does, right? So it's kind of hard to explain. And a lot of these tools fall into that category. Then you have tools like Hadoop, which is kind of taking like a bunch of different data piles and combining them all into one structure, and then using Hadoop to traverse all those structures simultaneously, right? And that's where we get into data mining and data warehouses and things like that. And then we have Azure, right? And really, it should be on the list here, but it's not. AWS. Does anybody know what that acronym stands for? AWS. Yeah, you can ask your AI if you want. AWS stands for, Chris?
Amazon Web Services.
Yeah, Amazon Web Services is the correct answer. And that's basically the cloud portion of Amazon. And then this is one of those weird little tidbits I always tell people. Amazon now is the world's largest retailer. They sell more stuff retail to consumers than any other organization. So like you go to Amazon, you buy your stuff, it gets dropped off at your door, right? So Amazon sells more stuff than Walmart does, by far, by the way. like on a like ridiculous scale. They make Walmart look like a mom and pop on Main Street. They're so big. Right? And that's not where they make most of the revenue. Here's the mind blower about Amazon. Amazon makes most of its money because they overbuilt all their computing infrastructure. They have their own data centers. They build all these computers and they only need maybe 10% of them to run Amazon. And then they take the 90% of the other computing power and they sell it to others. Like who? Netflix runs on top of Amazon. Right. That's just one example, right? A lot of people use Amazon to store their data, to run their computer systems, to run their apps, to store their data, to run their databases. And Azure is Microsoft's equivalent. So when Microsoft is building their data centers here in our area, it's to support what we call the Azure cloud, the Microsoft cloud infrastructure, which can do the same thing. What can you do in Azure? You can store data, run databases, run servers, apps, no code, machine learning. Oh my God, you can do so much crazy stuff. It can even begin to list it, right? And how is that data structured? I don't know. But it does all of it, right? So unstructured, structured data, all of it. And they call it an unstructured data tool because it can do everything, basically. That's the crazy part of it. So when they're building those data centers, it's just to support this. And notice the data centers aren't built yet, but they're coming, right? So they know in the future, this thirst for data is just going to keep growing. And where are we going to put all that information? We know it's coming. You know, it's like if you're having kids, you better build those bedrooms before the kids come, because otherwise you're going to buy bunk beds, and that might not be so comfortable. All right, we're going to talk about data mining, but we are going to take a break. So I'm going to pause the video here. And last week, all right, let's talk about data mining a little bit here. You know, because this is a term that people have been kind of throwing around for the last decade or so, and a lot of people really don't know what it means, right? You know, formally. I'm also noticing my little doodads here blocking the camera, so I'm going to move them. So let's look at the definition. It's the process of extracting information from raw data, and notice valuable information from raw data, consists of patterns that we can use as insights that are useful for our business needs. It's an important component for creating AI models, which is one of the reasons we talk about it here. And it's also critical in, you know, basically generalized analysis work, so business intelligence and data science. Very much used in those areas because often we're dealing with digging in to find very specific types of data. All right, they have a little list here, right? And mind you, these are the popular data mining techniques. And you'll notice that some of these things are things that we have talked about in the data analytics class that some of you are currently taking, right? So some of this will sound a little bit familiar. So something in the order of like data cleaning and preparation. So like when we open up a file and it's got bad data in it and we have to fix it, that's part of data mining. That's kind of weird, right? But looking at other things like classification or association or outlier, regression, prediction, and then we get into things like sequential patterns, decision trees, statistical techniques, visualizations, the neural networks, and all that stuff. And then we get down to like data warehousing and some of the other things at the bottom, including machine learning and AI, right? So those are all data mining techniques. So in other words, a lot of the stuff that we do with AI and the kind of AI that we're doing is basically applied AI, right? So we use it to do specific types of tasks. That's an aspect of data mining, right? It's you know, using those patterns and stuff and models to kind of drive decisions. So we're going to kind of go through a few of these here. Let's talk about data cleaning and preparation, right? So there's a whole bunch of different ways that we do this, right? So some of it is real basic, like sometimes like Here's the file. Like, and that's kind of like how your homework's been so far. Here's a data file. Or you go to a repository like Kaggle, right? And you find the data. And you would hope that it's okay, but sometimes it's pretty raw. Sometimes it's already really well structured, right? But you do have to look at it. Sometimes you have to transform the data into other things or process it in some way, organize it, clean it, etc. That's not abnormal. Classification is another thing that we do. So like when we look at a bunch of what we call independent variables, right? So you can see that like, so it looks like pictures of fruit and food or something. And we have some sort of a model set up, usually a math model, that recognizes like what is a vegetable versus what is something else, a cupcake. I think those are. So vegetables are groceries, basically. But we're categorizing things basically with that approach. There's also the prediction piece, right? So like if we see, for example, that you do a certain thing and something happens every time you do that certain thing, it stands to reason that if you do that again, the same thing will happen, right? Or if you see a trend, every time I do this, it moves a little farther that way. It's a prediction. This is a very common thing we do. So like, for example, when I mentioned before that, like a lot of businesses know that if, hey man, if I can just get the people through the door, the more people I get through the door, the more sales I make. So what's the trick of business? Anything I kind of get people through the door. If the business is online, well, the more people I get on the website, the more stuff I'm going to sell, right? No brainer. There's a direct correlation to that. Sometimes there's a pattern, and they use these like kind of like goofy little, thing with the cats here, where the cat eats and then it runs around and then it gets tired and it goes to sleep, right? And then it drinks some water and it does some work and then it plays, or whatever. There's a process, there's a sequential pattern. And for you, all of you that have done Python programming, right? You recognize that in programming, that's one of our problem solving steps is there's a sequence of steps that you take or an algorithm that always kind of leads to a certain kind of an outcome, right? So like if we see patterns, um, and you identify those patterns and those patterns work, you can leverage those patterns, right? So for example, if I run a retail store and I have a product that I have a lot of that I want to move and I want to sell it at a good price, it might make sense to put it right when the people walk in the door. Or here's an example. If you go to like a Walmart or something, or you go to a grocery store, why do they put piles of stuff right in the middle of the aisle? Because it works. That's why, right? So if they put the cereal and they put it on sale and they leave it in the cereal aisle, well, on the shelf where it normally goes, you may or may not buy it. But if you make a big pile of it and you say sale, people are going to buy it. It's a pattern that is very predictable. Data warehousing is kind of a thing. In the past and current still, we store stuff in databases, right? Databases are highly structured. However, there's nothing that says you have to do everything in a database. You could use unstructured databases too, and then combine them together, right? So cloud data warehouses are becoming very popular because so many businesses generate so much data, they don't have time to necessarily structure it. But they still grab it all. All right. Some of the other techniques, right, that they're kind of pointing out here, and I know we've talked about this in the other class, but these all have their own different things. We've talked about some of these during our class sessions here, or we've talked about it in other classes where it's pertinent. And those are techniques that we employ. It's all situationally dependent. Okay, so overall then, what is data mining? It's ultimately finding patterns in the data that's recognizable. And they're saying, find patterns out of all the unsorted data, or to find actionable tasks that we can take insights from that are gained from those patterns, and then ultimately to meet the business needs, right? So why do we put that big pile of cereal in the retail store right when people walk in because we got a ton of it and we want to move it, right? If we hide it in the back, nobody's going to buy it. Right? You put it out there because you have a need to do that. There's things that can interfere with this process, by the way. So like if you don't have data that's complete, or it doesn't, or it has a lot of stuff in it that doesn't make sense, problem. If the data is super, super complex, so in other words, their example is data comes in a different format, hard to concentrate on non-necessary information. Yeah, I mean, that's an issue too. Especially if it's raw data and you don't know what the data means. So you just got like a spreadsheet full of numbers. What are these? There's no column headers. Another big concern these days is this issue of data privacy and security. And unfortunately, a lot of people fall victim to this constantly, right? So I was just reading an article on this. I thought this was pretty fascinating, that a ploy that a lot of hackers and malware people use these days is they convince people just to go to their websites and use like a free tool or something. And the one I was reading up on in particular was like, oh, hey, I have, for example, a video file and I need to convert it to a different format. And I go to this website because they do it for free. Well, guess what the trade-off is for free? They read the contents of the video file and extract your data from it. And sometimes you have private information in there. And you know what? There's also this need of knowing information, background information, demographic information, like what data you actually need to do a particular kind of task. Sometimes you don't know what that data is. That can be an obstacle too, right? The privacy and security one is one that really resonates a lot these days because people do offer up a lot of information unknowingly, right? I'm going to run this video here. I don't think it's too long. I'm going to turn on the captions, so just fair warning.
Can you please just hear me out?
Sorry about the ads. I'm going to talk over the ads so it doesn't resonate too much. Here we go.
Data. That word is everywhere these days. Every company is dying to tell you about its big data, data analytics, data privacy, data warehouse, data lake, data. And at the center of the data mania is data mining, the practice of sifting through all those piles of information for insights. Data mining recently made big news with the Cambridge Analytica scandal. The political consultancy reportedly sucked up data about millions of Facebook users without their knowledge, then used it to profile and sway voters in the US, UK, and elsewhere. And similar techniques let companies like Amazon, Facebook, and Google work out what we want to see or buy, sometimes with shocking accuracy. It's a little creepy. It's not just ads and politics either. Data mining allows airlines to predict who's going to miss a flight, it tells big box stores who's pregnant, it helps doctors spot fatal infections, and it's even enabled cell phone companies to predict massacres in the Congo. The power of data mining and the hype surrounding it can make it sound like a magic wand, one that will either save your business or sink democracy. Of course, data mining doesn't really involve any unicorn hair or phoenix tail feathers. It's just applied statistics, searching lots of data points for patterns that humans might not spot. Those patterns are based not on human intuition, but on whatever the data suggests. So sometimes they can seem incredibly subtle or even alien, but there's no more magic in data mining than there is in a weather forecast. In fact, data mining is a lot like meteorology. Meteorologists aim for two things. First, they want to describe patterns in the weather to boil down its massive complexity into a few numbers and equations. And second, they want to predict Tuesday's weather. That's the whole point. Similarly, Spotify's data scientists might be interested in describing medieval rock fans and recognizing them as a group distinct from nerdcore or freak folk fans. Yes, that's a real subgenre. Ultimately, though, what's most important to companies like Spotify is predicting what each person wants to listen to. The key with data mining is that it achieves description and prediction not through careful study by experts, but by analyzing large amounts of data. In Spotify's case, that might mean scanning for patterns in genre labels, acoustic attributes, internet reviews, and anything else about each track, plus the age, location, friend group, and other scraps of information about each user. Data mining is more about spotting patterns than explaining them. Of course, the words pattern and data can mean just about anything. There are no clear definitions for data mining, data science, or big data, and they're sometimes used interchangeably with each other or with machine learning. That's why it's so easy to slap these buzzwords onto any project for instant venture capital karma. That being said, a few types of techniques consistently earn the data mining label. The most broadly applicable one is classification, where you try to categorize things. For example, Target famously realized as early as 2002 that they could guess who was pregnant and send them baby-related coupons. That's a textbook classification problem. Target needed to assign each customer to one of two categories, either probably pregnant or probably not pregnant. Classification typically works in several stages. First, each example or instance has to be broken down into a collection of numerical attributes or features. For a store like Target, an instance might be your mom 7 months before you were born. The features would be things like how many bottles of unscented lotion did she buy in the last 3 months? How about in the quarter before that? And likewise for zinc supplements, Asian pears, and every other product in the inventory. The store would also need labels for some chunk of the data, the ground truth about whether those customers were pregnant. Target got those labels from baby registries and due dates customers had shared. Once the data's all lined up, it's time for training. That's where the system tries to tease out patterns from all the labeled examples. Learning to classify is such a basic common need that dozens of algorithms, the mathematical procedures computer programs follow, have been devised for it. Which algorithm works best depends on all kinds of factors, like how many categories there are and how different features are connected to each other. But many classification algorithms are similar in that they treat each feature as a drop of evidence for one category or the other. The features get weights indicating how strongly they boost or weaken someone's chances of falling into the yes category, that they are pregnant, for example. Those weights are what the system learns during training. Basically, it's figuring out how informative each attribute is. And finally, to classify instances the system hasn't seen before, it puts together all the weighted contributions and maybe stuffs the resulting number through a bit of mathematical machinery to slide it up or down. If the result is negative, that instance goes in the no bucket. If it's positive, load up on those crib coupons. Each individual feature doesn't tell you much. In fact, many turn out to be irrelevant, but together they can be really powerful. Target's approach worked so well that when one customer complained that his teenage daughter was getting coupons for baby clothes, he ended up apologizing to Target. It turned out the company knew about his daughter's pregnancy before he did. Classification is useful anytime you want to tell one group of things from another. Insurance companies use it to guess which elderly patients will die soon so they can start end-of-life counseling. And doctors use it to check whether premature babies are developing dangerous infections, since the classifier can put together subtle disease indicators before humans would notice any signs. I could spend all day listing uses for classification, but it's far from the only type of data mining. One close cousin is known as regression. And no, that doesn't mean deciding you like Limp Bizkit again. In regression, instead of predicting a category, the goal is to predict a number. Take Target again. They wanted to know not just whether each customer was pregnant, but when to send each coupon. So they managed to estimate due dates too. And that's a regression question. How many weeks until the customer gives birth? Regression often depends on dozens or even thousands of variables, the features that describe each example. It finds an equation or curve to fit the data points, telling you how high you'd expect the curve to be given any arbitrary input, or in this case, how far away you'd expect the customer's due date to be. Like in classification, many regression techniques give each feature a weight, then combine the positive and negative contributions from the weighted features to get an estimate. And also like classification, regression is used everywhere. One of the better known examples is Google Flu Trends. In 2008, it began publishing real-time estimates of how many people had the flu based on searches for words like fever and cough. Regression is also part of predictive policing software, programs that look at historical data to guess how likely a crime is to occur in each area. The third major data mining technique is clustering. As the name suggests, the goal here is to group data points in a way that helps with the analysis. In the marketing world, clustering emerged in the 1980s, well before data mining, with the work of a market researcher named Howard Moskowitz. He struck gold when he realized that there wasn't one best pasta sauce. Consumers showed 3 distinct types of preferences, and the previously unrecognized group that craved extra chunky turned out to be worth millions. Clustering is often used to analyze market segmentation like this, but to understand how the techniques work, let's take a different example: eBay. On eBay, you can get millions of products, from antiques to zip ties. Even within a single category, like electronics, the selection is overwhelming. So eBay organizes things into subcategories. But it's a pain for humans to trawl through all the electronics, identify subcategories, and assign every product to a subcategory. Instead, the company can use clustering to automatically group the products. Again, each product first has to be broken down into numerical features, like how many times printer appears in the description, or who manufactured it. The simplest clustering method is to guess how many distinct subcategories there should be, then you randomly lump items together into that many clusters, and keep shifting items between groups to make each cluster tighter. In the end, similar products end up settling into clusters together. But we don't have to stop there. The blue and silver versions of the same camera don't really deserve separate listings. They're variants of the same product. So in addition to subcategories, it would be nice to find listings to merge. Sites like eBay can do both simultaneously with a technique called hierarchical clustering. Rather than a single set of categories, hierarchical clustering produces a sort of taxonomic tree. For example, it might find that cameras are much more like each other than like TVs. But within cameras, the DSLRs and point-and-shoots each get their own subgroup, albeit slightly less distinct ones. And within those are many different models, each with a few variants. Companies like Cambridge Analytica use these techniques to look for groups of voters who will respond to the same kinds of advertising. And Spotify can use them to guess who will like similar music. The fourth staple of data mining is anomaly detection. It's basically a special case of classification, identifying instances that are unusual or worrisome. The IRS uses anomaly detection to spot likely tax evaders, and credit card companies use it to flag transactions that don't fit your usual buying habits. It also helps industries with heavy-duty equipment. For instance, power companies and airlines can see when a generator or a jet engine is starting to vibrate differently than usual. Some anomalies can be detected just by looking for deviations from averages. Fancier techniques include looking for instances that don't match any cluster, or comparing instances with the closest other examples to see if their feature values are far off. Finally, association learning learning reveals which birds are of a feather. The idea is to look through, say, millions of grocery store purchases to see what gets bought together and when. A classic example is the Osco drugstore chain, which once found that many customers bought beer and diapers together on Friday evenings. Contrary to popular legend, the store never acted on this profound insight, but stores regularly use observations like this to optimize their floor layouts and inventory. For instance, Walmart discovered that shoppers buy lots of Pop-Tarts immediately before hurricanes, so it started to stock up. Association learning has broader applications too. Celltel, an African cell phone company, realized it could spot impending massacres in the Congo when everyone nearby started buying prepaid phone cards. So the 5 strategies we've covered, classification, regression, clustering, anomaly detection, and association learning, form the backbone of data mining. What makes them so powerful is that they offer standard mathematical tools you can use for everything from curating Facebook feeds to optimizing store layouts. But that ease of use can also lead people astray. Data mining is just one step in the process of extracting knowledge from data, and it's all too easy to whip out an algorithm without carefully selecting the data, massaging it into the right form, and considering how to interpret the results. Remember Google flu trends? It shut down after a few years, but not because the algorithm was broken. Search auto-completion had totally thrown off the data, and engineers had given it too much leeway to interpret seasonal words like snow as evidence of the flu. And then there are the queasy social implications of sharing data in the first place, and of letting companies form such an intimate understanding of our behavior. In other words, the creep factor. So as powerful as it is, the math of data mining is just the beginning. Sometimes the hardest part is all the messy human stuff. Thanks for watching this episode of Sci.
All right, folks, I know that was a longish video, but I think he presented a lot of really good information there pretty quickly. I did turn up the speed a little bit, so if it was running a little fast, you can go back and watch that one at regular speed or even slow it down, I guess. But I think he did a great job of explaining stuff. And yeah, people do look at data in a lot of different weird ways. And yeah, there's a kind of a little bit of a creep factor to it, for sure. Now, let's start looking at how Gen AI stuff is kind of infiltrating into this area as well. You know, the generative models that a lot of us are starting to use, and we're starting to use a lot of these engines now to do a lot of different tasks. Right, we've talked about a lot of this stuff. So we use them to find patterns that humans don't see. They can create synthetic data that help to train models and things like that. And they help us make decisions about things often because of how they're built, right? There's a bunch of different types of generative models that we can use, right? Some of these we've explored already, some of them we have not. So like the one that we have looked at was the generative adversarial network, right? Where the model itself is trying to create a fake that it can't detect itself, right? So that type of thing. And each one of these, by the way, has situations where they work really well and situations where they kind of don't, right? And so that's why we have different ones. Finding and discovering patterns is one of the more powerful aspects of this, right? So when you have ridiculously huge amounts of data, it becomes very difficult both for the human brain and mind, and really our capacity to just kind of stick with it, to process all this information. And that's why software tools really become very useful in this capacity. But when he was like talking about anomaly detection, for example, and I know that this may have happened to you, and I know that's happened to me many times. It's like, all of a sudden, there's a debit card transaction in Milwaukee, and then like 3 hours later, there's a transaction in Texas. Well, yeah, that's because I flew to Texas, but the credit union didn't know that, and so they blocked the transaction because I didn't let them know, right? Because it's an anomalous transaction, and thank goodness, right? That they do that, because what if somebody did steal your information, printed a fresh card, and kind of moved on. The other thing that's kind of good with generative models is sometimes, and we see this in our data analytics course, like we were talking about the Electoral College, right? Like, why did all of these southern states not have any electoral votes in the year 1864? Well, that's because they weren't part of the Union in 1864, right? However, if data is missing, generative models sometimes can fill in the gaps, especially if it's data that's predictable, right? So there is value to it there. However, right, can that always be accurate? Who knows, right? They do use it for anomaly detection quite often. I think there's a lot of questionable ethics in this aspect of it. You know, for example, when he was talking about how insurance companies like make predictions, you know, like why is it that one person lives in one place, has a certain kind of car, and a different person lives in a different place and has the same car, and their health or their car insurance rates are so insanely different. Well, that's because where the one person lives, there's a lot of thefts or accidents or whatever, and the other area there is not. One guy keeps it in the garage, the other guy does not, right? You know, so um but insurance companies in particular have kind of been taking a lot of flack because a lot of them do use tools like this to kind of make decisions on claims without even getting people involved. How does that make you feel? So if you put the wrong thing on your claim form, they just deny you automatically just because you didn't say it well. Yeah, so those are some questionable aspects of that. Generating text and language is kind of a big one too, right? And they talk about this RNN thing, this recurrent neural network. And we're seeing a lot more of this, by the way. A lot of us have gotten very, very accustomed to using text-based assistants, like on our phones or on our computers, or interacting with chatbots, not even giving it a second thought anymore, where in the past that was such a weird thing. How about the language translation one? That's kind of one of those things. Like you're searching something on the internet, you end up on an international site. They don't have a translation tool built into the website, so you copy the text, you paste it into Google and say translate to English. And what if the translation isn't right? Is there anybody here that speaks a different language and has tried that? Because for example, my first language is not English; it's Greek, right? And there's some phrases that people say in Greek, and I've seen them dropped into translations engines, and I'm like, that's not at all what that means, right? So even though it's like translating the words, it's not really translating the meaning correctly, right? That type of thing. So once again, very handy, and I think those tools are getting better now than they used to be, but they were pretty rough at first. Another thing is to enhance data privacy, although it can be used to counteract it as well. And this is kind of an interesting thing. They say generative models can preserve privacy by generating synthetic data that does not disclose synthetic information. For example, and I don't know if like a lot of you are aware of this, but like sometimes, like I use tap to pay on my phone as a good example. And when I use that, depending on which card system I'm paying with, so this kind of gets very technical, but some of the banks I contend with, whenever I use tap to pay, they don't actually use my real card number. They generate a synthetic number for every transaction. That way, if somebody grabs it, the next time they go to use it, it doesn't work because it was a one-use number. Very, very interesting. So I mean, there is some cleverness happening here. So we have hackers that are clever, but we also have people that are protecting our data that are clever as well. This stuff is going to keep evolving is really kind of the point of this. Some of that evolution is happening right before our eyes. I was playing with some generative AI tools last week that completely blew me away. And I kind of feel compelled to share this with you. So this is going to be just a moment here, because I probably should obscure my screen for a moment. I'll actually pause the video. Right. And so as the slide says, yeah, they are really helpful tools. So a lot of the generative AI engines now are being applied to some of these data mining tasks. And then we're seeing a lot of like power significantly growing. And it's that data mining capability that those engines and models have that really kind of take it to the next level. They have a series of questions there, which we're going to skip over. Now, we get into this issue. So we have all this data. Where the heck do we store it all? Right. And we talk about this in principle, but now we're gonna dig in a little bit deeper. So the files that we do try to store are digital files, documents, whatever. Typical storage systems of the past can range from anywhere from floppy disks. And the other day I was doing a little cleanup here in my workshop, and I'm looking, I found an actual floppy disk somewhere. Here it is. Right. And what so I'm just gonna hold this up. Of course it doesn't show up. I gotta put it in front of my face. Right. A little 3.5 millimeter 1.44 megabytes of data fit on this diskette. And that was revolutionary at the time. Even more ironic, this was actually from a Macintosh, not from a PC. And so I wonder if it even still works, but that was when I first got into IT, that was like our primary storage mechanism, right? I could barely put anything on this, right? Like I can't even put one photograph on this diskette. It's got so little storage on it. We moved from there up to hard drives, and I don't have too many of those floating around here anymore. I just got rid of a whole bunch of old ones. And so those are electromagnetic physical disks, like a old-fashioned hard drive has metallic platters inside of it that we encode magnetically. And then we have our optical disks like CDs, DVDs, Blu-rays. And then we had lots of other weird storage mechanisms. So we have like SD cards and micro SD cards and flash drives and all those types of things. Some of those things now are inside of our computers and a lot more efficient. And I, for example, have just added to my computer here, I bought myself a 4 terabyte SSD drive because I was running out of data storage space, right, on my own machine here. And man, what a difference to just have tons of room to put stuff. I had a terabyte before. It was an old-fashioned spinning platter drive, and now I have an SSD, which is like a giant flash drive. And I went from like having like redlining my drive like 99% full to like I got tons of room. I can put everything I want on there. So the technology, or at least our approach of the past, was when we have files that we want to store, we have like disks or drives or whatever, and we store them on our computer. Great, right? However, right, and I'm doing a little sideline here. I look at my own system, and I'm bringing up a file folder, right? And what I'll just kind of show you, right, is I did my upgrade. I cleaned off my main drive. It's still only a 500 gig SSD, but I'm going to upgrade this too eventually. But this one went from a maxed out 1 terabyte drive, and I added some more files, you can tell here. But now I have all this extra space. I got 2.5 terabytes free on a 4 terabyte drive, basically. And then I have my C drive, right? So these are both physically on my computer. Right? These are drives that are inside of my computer. I can also plug in external hard drives and whatnot. But then right here, I have another drive, and this is a cloud drive. The files here, this is where I put all my school stuff, by the way. This is in the cloud. So when I go in here and I, dig into, bring up a course, like something like this, this stuff is not on my machine, even though it has a drive letter and I'm accessing it through my file explorer. This is in Google Drive, where, I don't know, somewhere out on the internet. I have no idea where the files actually are stored. The way that I access this, of course, is I have running in my system tray, and you can't see that because I'm in PowerPoint mode here, the Google Drive software that turns my Google Drive into a drive letter and allows me to interact on my own computer system as if the files are here, but they're not. These are all on the cloud. A lot of us who are using Windows also have OneDrive accounts, especially if you're using Windows 10 or 11, that's kind of automatic these days. I have a OneDrive account for my gateway files, and I have a OneDrive account for my personal stuff. And most of our modern machines, and you guys should know this, will automatically sync key folders from our computer to our Microsoft OneDrive account. That's actually a great thing, right? So if I'm saving a file here in my documents folder, it automatically goes up to OneDrive. And that way, if somebody steals my laptop or spills a soda in it and blows up, my files are still safe out in the cloud. But think about this. If you just save your tax files in your documents folder, they're on the cloud. But now how do you feel about it? Yeah. And so, and I just kind of give this as a tip. I do not have my documents folder upload to my OneDrive. I have them disconnected just for those kind of reasons. Not that I don't trust Microsoft or that the files are secure, but if they're out in the cloud, there is that possibility somebody could access them. Now, and what you'll notice here is I run a bunch of different cloud services. So I have Google Drive running, that's my G Drive. I have 2 OneDrives running. I also have Dropbox running, and I got a couple more, right? And all of those are in the cloud. Some of them replicate on the local hard drive, some of them don't. So in other words, some of them will have physical copies here and out in the cloud. My Google Drive is just in the cloud. And so these are choices that you make when you work with these technologies. Why is that a good way to work? Well, I think I already explained it. If I keep a lot of my important stuff that I'm working on, especially stuff I'm working on currently out in the cloud, if I have a problem with my equipment, let's just say somebody breaks into the house and takes all my computer gear, I still have all my files. Right? So there is a huge advantage. There is kind of this move, right, both in we'll call it industry or enterprise or organizations and in personal computing, where they do want us to use cloud storage because of that safety factor. But I do have deep concerns, right? Because a lot of times that storage is free. And what's the cost of free? Are you giving them permission to look at your stuff? There are, and so if you guys are asking these questions of yourself, there are cloud storage services that allow you to encrypt your own stuff and they can't even look at it. Where Google or Apple, like if you use iCloud, for example, if the government says, hey, we want to look at so-and-so's files, we got a warrant, they're going to show it to them. So be careful what you put in the cloud this one. Tell me. Okay, so talking about data, and I think we've looked at I think this, you guys remember this in the data analytics class? We looked at a graphic like this in one of the early weeks, like how much data is generated every minute. And this is kind of I don't know what year this one was generated in, but this is like an insane amount of data that human beings create. This is based on 2018 data. And they're saying here, can you find the latest information for 2020 or 2021 or 2022? And how much is this growing? And they have a little graph here that shows how much it grew from year to year to year. But I can tell you that going into the future, that graph is kind of curving upwards rapidly. Because think about this. How many of you were storing your files in the cloud back in 2016? I'm going to wager with a really high certainty, very, very few of you pretty much were an IT geek back then. In 2025, when you load up Windows 10 or Windows 11 or the Mac OS on a new computer, it automatically syncs your stuff to the cloud. That alone has made it grow. And then everything we do generates data. It's a crazy growth rate. So they're talking about how do we store files? So these are kind of the 3 primary approaches. Direct storage, it's either in your computer or attached to it. That's what that means. Network attached storage, we have some sort of a network, maybe in the house or maybe in your organization. And a lot of us will have routers, for example. I have one that has a USB port on it. And if I want, I can attach a hard drive to it. And I could put, for example, all my movies and TV shows on there and the whole house can, so that would be network attached storage. It's not attached to a computer, but it's on the network. Workplaces typically have this kind of storage. And then what a lot of people are doing is they're moving their storage to the cloud because now they don't have to pay for the equipment. They pay for it as a service. And organizations, right, typically when the stuff is attached, they call this on-prem, meaning on premises in the building, right? Or cloud, it's either on-prem or cloud. And a lot of companies, and I say like 5-6 years ago, there was a big move. A lot of people were moving everything to the cloud, and some companies now have kind of halted that and like, there's certain sensitive stuff we really don't want to put in the cloud, or we get better performance if it's on-prem. And granted, you still have to pay for the equipment if you're doing it that way. So it's direct storage. Okay, so this is what we were talking about. This is the stuff that's in your computer or attached to your computer: hard drives, SSDs, CDs, DVDs, sorry, USBs, portable hard disks, and whatever, however you store your files. And if you guys aren't in this habit, right? So you guys are data people. If you have information on your computer and you're not backing it up somewhere, I'm just telling you this right now, you're asking for trouble. It's like driving a car without insurance. Eventually you'll get in an accident or something will happen. Heck, if what happened during the data analytics class is an example, my computer blue screened. I haven't blue screened on this machine in years, right? Where it crashed. What if my machine didn't recover? Yeah. Or what if it, like, the data gets corrupted, your hard drives fail? You should be making backups of all your data, even if it's, you just buy an external hard drive, plug it in, and copy your files every once in a while, right? When I ran a business operation, we did daily backups of all our data, and then every week and every month we would do complete imaging. So like we had so many backups because if we lost our data, we couldn't operate the business. Right? We rely on the data, so it's important. Back up your data, folks. Network attached storage. This, once again, this is where we call this on-prem, right? So like we would have like maybe a server room in our business, and there might be some devices in the server rack that are just a collection of hard drives. And then when you back up files from like a different computer or from local machines or whatever, it all goes into that repository, right? So good examples at the bottom there. Internal data, the intranet data for colleges, yes, for sure. Or data stored in a bank's data center. Yeah, they're not going to put that out in the cloud. That's going to be in the bank. It's attached to the network. Right. And so I'm not going to go into this RAID video here, but if I would encourage that you watch this if you're a data nerd and you want to learn about it. There's kind of an approach, right? So like when you have a lot of data on a machine. So I want you to think about this. When we have a personal computer, we have like one hard drive, maybe 2 hard drives in it. That hard drive fails. If you don't have a backup, oh well, you're starting over, right? If you have a backup, you can restore it on a new drive. If you're in a commercial environment though, let's say you're a bank and all of the account information, like how much money is in every account, that's not information that can ever fail. Do you understand where I'm going with this? When you work with network attached storage, one thing that they do is they'll take, for example, what they call a RAID, which is a redundant array of independent disks. So instead of using one hard drive, they'll use anywhere from 2 to 10 hard drives, basically, that all basically hold the same information or portions of the same information. So if one hard drive fails, you can just pull that hard drive out, drop a new one in its place, and they call it striping. It's more of a technical thing, but then the data recovers. You never lose your data, right? And those types of systems, typically, those types of servers that run that kind of stuff, usually will have multiple power supplies. So one power supply goes down, the other one kicks in. They have redundant network connections. They have redundant internet connections, with different providers, right? Big organizations that rely on their data never go down. They can't. What would happen if your bank didn't know how much money was in your account? That's not even allowable, right? It's not even conceptually allowable. Right. Okay.
When
We're not
Brad
watching the
Schimmel
video.
was Wisconsin.
Sorry. Then we talked about cloud storage. It kind of gave you the lowdown on this. So these are probably the four most popular cloud storage things. Google Drive, OneDrive are ones that we use a lot. iCloud if you're a Mac person or an iPhone person. The big independent one was always Dropbox, and real frankly, out of all of these services, Dropbox is still my favorite. It works the best and the fastest. However, it is also the most expensive. I've broken down now where I pay for my iCloud and I pay for my Google Drive because I have so many files. You know, like every time I take a picture on my phone, it automatically goes to my Google Drive, right? For the same reason, you know, I talked about before. And of course, I filled up my free storage. And then also I discovered that by paying for it, they changed the privacy aspects of it. So if you're, and it's not really expensive, by the way. I think I pay maybe $1 or $2 a month to each iCloud and Google Drive for extra storage, and it's worth it, you guys, right? It's not a lot of money for a peace of mind, for sure. There's a bunch of stuff that can happen in cloud storage, though. What if somebody compromises the cloud storage? Yeah, that's a weird question, right? So I'm putting this stuff in the cloud. Is it actually safe? Right. So I'm not that I'm paranoid, right? Because I know that there's ways I can encrypt my data in the cloud, but there's certain types of information I will not store in the cloud. I just won't do it. Right. Tax records, personal, really deeply personal data kind of things, I just won't put out there. That's a personal choice. Other people feel differently about it. It's like, yeah, I have you know, my tax records are out there, thank God, because I lost my computer. Chris?
Yeah, no, that's interesting to me. I just was curious, is so if like if you feel more like less safe having information on the cloud, as far as like an enterprise would go, would they feel the same? Is there a hierarchy on what's more secure between attached storage or cloud storage? Like if especially if they're like running, you know, like local LLMs or using a different LLM or something?
Yeah, I mean, you dig into some really good heavy hitting questions there for sure. I mean, it becomes a highly personal choice on the level of the enterprise. Like, if you guys come to our advisory meeting, we had a conversation like this. I don't know if it was the last one or the one before that, where we talked about like, yeah, we were moving everything to the cloud, and then, you know, there were certain systems we didn't really kind of want to put out there, you know, for what I mean, they were either technological reasons that wasn't compatible, or the response time of the system was slower, or they weren't like, hey, those are our company. It's like KFC putting their secret recipe in the cloud and somebody's stealing it, right? Or the formula for Coca-Cola or something like that. Yeah, there's certain things they just don't want to divulge because business, um, you know, the businesses attack each other like or countries attack each other hacking wise. They do anything they can do to steal company secrets because that's often how they operate. Yeah, so there is that thing. Now, granted, I can put stuff in the cloud and make it in principle just as secure as anything I would have locally. But the big aspect of it is if it is in the cloud, it's potentially hackable. If it's on-prem and that storage location is not accessible via the internet, you're never going to hack it. You want to stop somebody from hacking, pull the cord on the internet. Done, right? There's no hacking going on there. These are deep questions, and you know what? If any of you do come to the advisory and they start talking about this stuff, ask a question. Like, how do you guys secure your data? You have it in the cloud. And what we generally see is some companies are cloud 100%. Other companies are like, we're not necessarily trust that cloud thing. What can you do to mitigate the risk? Well, you have to really kind of think about how your data is structured. You can run your entire organization in the cloud if you want. A lot of companies do, but they do things like clever things like they encrypt their file systems. They also use encrypted communication channels, right? So there's ways you can work around it. Some pertinent questions here. We are just about done with the slides, if you guys are wondering, so we're getting pretty close here. And we will finish in time, believe it or not. But here's some questions. They have a kind of a list, right? So like, what needs do you have for your data? Like, for example, I put all my school stuff on my Google Drive for school because I really don't want to store it on my computer. It sounds silly, right? Because for whatever reason, you know, when I was doing my new hard drive in here, I was processing all my old files that were on external drives, and I'm like, what do I need to keep? What am I? And I'm like, looking at all the stuff I used to teach in the past from like 4 or 5 different schools, and I have all my files, and I have all my computer files, and all my resumes, and all my emails, and all my games, and all my documents from when I started computing. All of it. I captured all of it. Can you imagine that? But there was a point in time, you know, like for example, when I was running my businesses, I saved all the emails in these archives or whatever. So if I ever wanted to go back, I could like trace down a conversation or something. But then I started thinking to myself, in the modern era, it's like, do I really want to store that? You know, now the school stuff is actually handy, right? So sometimes I go back to these really old examples for whatever reason. But there's a lot of stuff that I really never ever would go back to. So I'm actually considering now, maybe I time to clean up the attic and get rid of those data files, you know. So like, what are your needs for pulling data back? If you run a business organization, sometimes there's legal requirements. So for example, when I had a few different retail operations and private business things going, uh, I, I don't remember what the cutoff was. I think it was like 7 years, right? Like you have to retain all your files for 7 years, both paper, electronic, and whatever. And then I would keep them for 10. And I had shut down one of my businesses back in 2012. And it was just a month or two ago that I finally destroyed all the paperwork from it. Like, wow. And you know what? It was a dumpster full of paper. All of it completely useless. You know, none of it was important in any way, shape, or form. No important trade secrets. I'm like, why did I keep all this stuff? They, you know, whatever. But those are kind of the questions that you ask yourself. You know, data is important. You got to keep your data, but how long do you really need to keep it, and where do you really need to keep it, and how much are you really going to access it? These are all questions you have to ask. If you don't have a way, for example, to back up your data, you're asking for trouble. I'm just telling you that right now, because computers fail, storage mechanisms fail. I'll give you an example here. This device, and this is weird because I was just doing cleanup here in my workshop. I have this. This is an old external hard drive. Back in, I don't know, 20 years ago, I paid hundreds of dollars for this. I think it's got like 100 gig capacity, not terabyte, gigs, right? Um, and I got like flash drives that can, you know, got like, I can store like 500 times as much stuff on. But I paid a lot of money for this, and what was on this hard drive were all my sales records and shipping records for one of my retail stores. Every sale I made, every shipping label I printed, all on this hard drive. And I used to do backups, like I said, daily, monthly, weekly, all that stuff. It's all on here. I went to plug it in to see if it worked, and it doesn't even spin anymore. So here's a problem that happens with some of this old media. This is a spinning platter hard drive. If you don't keep using it and keep it spinning, it's like a car that sits for too long. It gets rusty and the wheels don't want to spin, and now it won't start. So I'm going to do the Breaking Bad thing with it. I'm going to take a drill, put it right through the platters, because believe it or not, people could pull the discs out. But you know what? I'm thinking to myself, who cares about my old invoices and shipping records? Here's the answer: nobody, right? So I'm going to take it to an electronics recycling place. There are places like that, and toss it. You see how big the thing is, right? And then I got like a little, I kid you not, little SD card. This is a big one. That can store more information than that hard drive. It's like this big, wafer thin. right? So these are, I think, pretty interesting things. These are all pertinent questions here on the screen. When you think about the fact that we have all these cloud services, though, and you don't feel safe about your data out there, one thing that you can do is you can zip your files and data and password protect them. You can encrypt your files and then upload them if you're really super paranoid. But this is a great list to work from. Yeah, this data storage is an important strategy, often overlooked, and I say this as a word to the wise for all of you, especially as you go into this field, that you got to be mindful of your data, where you're putting it, how you're storing it, how you're backing it up. If you don't have a backup plan, right? And by the way, the Mac OS and the Windows operating system both have backup tools built in. You can just use their tools, buy an external hard drive. They're not expensive. Heck, you can get a flash drive for most people is enough. And just every once in a while, copy your files onto it. And if you're smart, right, and this is like a recommended thing. I used to do this, is I would take a hard drive, fill it up with all my data, and take it up north to the cottage and leave it there. Because if my house burns down, the drives go with it, right? Yeah, I don't do that anymore because now I put stuff in the cloud, but whatever. All right. I'm not going to do the quiz. I think this is basically the end of the presentation here, folks. So I'm going to stop the